Great. Well, first, I just want to thank everyone for joining. Really appreciate everybody and joining us to really dive deeper into how to really leverage AI to drive manufacturing to new levels and really get incremental value, really take profits to the bottom line. We have a couple great guest speakers on today. We have Luis Solano from Google, who really is a lead over in Google in the manufacturing sector, and he's really going to help really walk you through all the innovation that Google's bringing to the table to help manufacturers digitally transform. We also have Derek Bliley from ClearObject, who runs product for ClearObject. He's really going to help talk about like really how you bring, how we've really been helping bring VisionAI to companies and what that journey looks like and some of the returns that we've seen from our customers in adoption of VisionAI. So we're really excited, and I hope really everybody's going to be really excited about the content and discussion. If there's not anything else, then we'll move on, and I'll hand it over to Derek, who will kind of walk through what's going on in VisionAI and really how manufacturers are using that to really drive value.
Thanks, Mike. So as Mike said, what I'll try to do is explain a little bit about how we're bringing that value to customers, what a typical engagement looks like, and kind of walk through those steps while trying to define as well what a vision system is. And specifically in manufacturing, where I'll start, is a lot of work being done at the edge, right? That's where a lot of the value is being provided to those manufacturers. So when I say the edge, what are the advantages of that? You have low latency. And you minimize the costs of having to stream data constantly to the cloud to where it can do the analysis. But ultimately, you're moving the intelligence closer to where the decisions need to be made. And so, through these examples, I'll talk about what are the steps to, really begin building a vision edge system, and then, what those pieces look like. So, what are the basic components of a vision system? It starts with image acquisition and image processing, and then really about the image analysis and the understanding. And then what's the integrations? Where's those actions being driven? Where's that output go to? So think of an image acquisition as just really saying, hey, how do I turn what is an analog image into a digital image? That then can be used by the computer to really understand and starts to make insights of that. Any image processing that's needed to prepare it then for our modeling, at which point then, leveraging kind of TensorRT, which, state of the art, allowing you to really support that real-time video analysis. And then custom insights, meaning that you can do more than just what a lot is referred to as a lot as machine vision, which is just a set of eyes, but ultimately more intelligence built into that. And then, the outputs of those systems, there's a standard OPC-UA is the industry 4.0 standard for how you can take the outputs of those systems and integrate it with your line to get real-time, almost closed-loop systems. We have examples where ultimately these systems are running in real time, making an analysis. That analysis and those results are being sent to PLCs, which are then actually making business intelligence decisions and modifying then what's being done on the line. And another thing that you can also do with the output of those systems is really send that to other locations, whether that is data storage locations within your cloud instance or web pages, to really start to see more trends over time and really get the insights that you might want out of those systems. So what are the opportunities, right? A lot of people ask, hey, okay, Derek, in manufacturing, what are my opportunities for vision? This is just representative images, a line, gypsum board manufacturing. And we've got experiences with use cases like this, but ultimately you could think of where are locations today where individuals are doing quality checks. Those quality checks, while they might be samples today, one thing that we can see with vision systems is that you can now get 100% quality checks. You can also get digital representations of all that data that can be used. So that's one place to think. Another place is, hey, where are we, where today maybe we don't have sensors that, hardware wise, we have not been able to use up to this point, that now with vision, we have the ability. So something maybe like a stream of a liquid and understanding how that stream changes over time. That can now be a vision system that can turn before what was unstructured data into structured data that allows you a better understanding of that. So really in any place in manufacturing, you're just looking at where are the areas that if I could, I would love to have information or really understand what's going on all the time. And that's kind of the simplest way to just think about that. So what does the journey, to vision look like? So I'll walk through a couple of these steps, just trying to highlight, lessons learned, pain points, really the things that you need to think about as you're starting to develop a vision system. And, the first thing is really just understanding what is the business use case. So, in manufacturing, what's really your objective? Are you trying to get to lights out manufacturing, reduce scrap, improve product quality? These are the standard things that we see, but ultimately, okay, if from that, what information would I expect to be able to see to be able to really justify the business case? And then again, going back to what is the action that's going to be driven as a result? If I can do this system, it does provide me the insights that I'm expecting. How am I going to update my processes? What does that change look like? Where does that information need to go? And really understanding that up front, because that'll help define as you develop your system as you move forward. And then really it's understanding about what's the riskiest parts of this operation as we move. From our experience, really when you start a vision system, and depending on your level of experience, is really just how do I know that the vision system is going to be able to provide the context or insights that I'm looking for? And that's typically what we hear. And so, the last thing you want to do is invest a bunch of money in, hardware and infrastructure to be able to say, hey, I invested. ClearObject that work very seamlessly with the Google Cloud environment, which allow you to really kickstart that initiative and capture data to kind of minimize that risk. So, these steps, while they're kind of sequential, the timelines can vary. We've seen use cases where you can get through steps 1 through 7 ultimately in one day. Typically it's about 2 weeks to be able to validate and build a model and demonstrate how it can work. Now there's some components of that that are all just dependent on the use case, obviously. But just to give everyone kind of a context of what it can look like to kind of justify and build that business use case, and then how quickly you can deliver and validate that you can move forward. So the first place you start once you've kind of defined that business use case is really around data capture and exploration, right? So this gets back to a little bit of, okay, how do I mitigate that risk? You want to think about, do I have existing infrastructure in place today? And when I think about infrastructure, do I have a vision system, a camera that's capturing data? Is that being logged anywhere? So that's the first place to start. And again, that's where you can minimize that risk by really kickstarting it without thinking about a full IT integration, but more of just how do I capture the data to validate the model. Then some other parts around the data exploration is really what's the insights that I'm looking to get out of that data that's been captured? And do I need subject matter expertise really to understand the insights that I'm looking for? Some examples of that may be specific types of defects that you really need the subject matter experts who are familiar with that product and that manufacturing process to really understand that. Just think there's a little bit of time and dedication that it takes for them to be able to apply their knowledge to that. But what we typically say, if a human can inspect it, so can the AI. It's at this point where we're really, your data scientists can explore that information, really understand the nuances, which is really going to help them in that next stage, which is selecting the algorithm. So that's based on a lot of that data exploration and what are the nuances that, and when I talk about nuances, it's more about what type of modeling, such as segmentation, object detection, classification. Examples of object detection would be identifying the specific defects within that. Segmentation might be understanding what in an image on a pixel by pixel basis is in that image. Classification more be, is this component in the frame of view or not? So data scientists can select that algorithm. Then another major component after you've selected that algorithm is, okay, I've got the vision, it's creating those insights. Take a segmentation example where maybe, going back to that original example, you've got a board moving through a line and you want to control the distance between those two boards. So a segmentation model would tell you pixel by pixel wise where each of those boards are. But if you want to control the distance between those, that's where some feature engineering to be able to say, okay, I want to use the mass that is those boards. I want to then understand the distance, and I want the distance between those boards to really be the output that I can control around. That would be considered part of that feature engineering. And then we're really just saying, okay, I'm going to take all those pieces, get that running, package it up, build that model so that it can run within the edge device, and look at really what are all those components that are required to move that forward. Once we do that, it's really about then, okay, I've got that model, I've built it, I've tested, now I evaluate that and look at how it's performing now back on that edge device. So again, some ways that you can drive adoption of this that we see really turning what things that used to be a black box around VisionAI into more interpretive. So being able to overlay the inference results in real time and display that information to users is really part of that evaluation phase so that your users can understand what's happening. And that can be anything from a web-based visualization to you might be putting a monitor right there on the line that your operator can understand and gain trust within that vision system. So a key component is just working through the process of all of these to make sure that users feel comfortable with what they're adopting and how they can improve their steps. So that's kind of the journey. Obviously after all that's been done, now it's a matter of integration with any IT systems, deploying that at scale and managing those, integrating potentially with other third-party systems within your manufacturing environment that you want to think about. But at the end of that result, now you know the VisionAI can perform what's needed. You know what the value of that business case is. You're able to use that data and those insights to understand, if it is a defect or it is, a scrap rate, how often was that occurring based on the modeling now that we see. So you really can justify your business case and have proof points to move that forward. And I think that's the most important piece. And, one final point, there's a lot of work now that you have these vision systems. There's a lot of work, what's the secondary benefits of that? We've been doing a lot of work in what we call soft sensor, what is a soft sensor? Ultimately, you could think about it as data that's now being created from software rather than hardware. So some of those insights coming out of our vision systems could be looked at as soft sensors. You can then start to combine soft sensor outputs with hardware sensors and really start to understand your full production line. Before I hand it over to Louise, what I wanted to just talk about is really some return on investment that we've seen with our customers. And so one client experienced a 20% reduction in scrap rate just on one line by introducing one of these vision systems. At the same time, using these vision systems on a different line, we've seen a reduction in carbon emissions by being able to optimize the raw material that goes into these, and the overall is over 500% ROI that they were able to generate as a result of integrating vision systems into their manufacturing. And I know I saw some questions pop up. We'll get to those here at the end. I'll hand it over to Louise.
Thank you, Derek. Appreciate it. I'm going to spend a few minutes. Thanks for joining us, folks. By the way, Luis Solano with Google. I'm an industry development manager for manufacturing. What that means to you guys is I'm an operations person, right? So I've been a plant manager, VP of Ops, SVP of supply chain. My role focuses on helping our customers understand how to apply technology to solve the problems that I've been trying to solve most of my career, right? And really get a sense of how do you apply some of these tools in manufacturing, which is a unique environment, a challenging environment. Every day is a battle to get the product out, quality product out. And so it's challenging to kind of step back and think about things like AI in manufacturing without getting all that work done. So I want to share a couple of thoughts. We can take a step up and talk about kind of Google's vision around AI for manufacturing. And for us, we look at it as trying to enable agility and innovation using data and AI, right? I believe that AI is going to be synonymous with manufacturing within the next 5 years. If you look at this slide, this is the concept of a digital thread just in picture form, right? You've got information from your as designed data set to your as purchased, to your as built, as sold, as service. And connecting all those data sets together is really a digital thread. And our philosophy is this, that we don't espouse having a huge digital thread project. It's something you arrive at over time, use case by use case. And the VisionAI use case that Derek just talked about is a perfect example. It stands alone from a value standpoint. It gives you one part of that digital thread, and you build on that over time. On the right-hand side are all the things that Google's focused on, right? Data analytics, table stakes, but it needs to be done. Machine learning, natural language processing, Gen AI, and then security and compliance. So we focus on those capabilities to really drive innovation in manufacturing. This is kind of the same view, just looking at it differently, right? It's about how do you basically gather customer data, that customer experience, tie it to manufacturing operations data, and then link that to supply chain logistics data, right? So it's just another way of saying digital thread. And ultimately, we try to help people from a solution standpoint that's more platform oriented, while our partners like ClearObjects work on specific use cases, specific capabilities. All right, so let's talk a little bit about what it looks like. Why do I think AI will drive the next evolution of manufacturing? If you look at the stuff in the middle of the blue dots, those are the things that manufacturers have been using for essentially centuries to try to improve operations, right? It's all been continuous improvement, whether you're using Lean or Six Sigma, regression analysis, operations research. Those are all things that I've done and worked on, and those have created huge improvements in the manufacturing world overall. At the end of the day, those things have limitations, and the gains that we're going to see long-term are going to come from AI. And I have a simple litmus test for people to do. Next time you're in a manufacturing plant, try to find a quality engineer or a process engineer and point to any machine and say, do you have all the data created by that machine? And 95% of the time, the answer is yes. It's in a spreadsheet. And you ask them, why do you keep that data? And they'll say, because I know the answer's in there. I just can't figure it out yet, right? The variables, the patterns are just too much for the human mind and for the tools we have. AI will find those patterns. So that's why we think about AI as far as driving the next evolution in manufacturing, and why we think you have to think about how do you apply AI in manufacturing specifically. So let's talk about what are we seeing out there in the manufacturing world from our perspective. A lot of data, not a lot of insights. A lot of MES and SCADAs out there collecting data, great. Limited automation decision making. If you look at the classical decisions, let's take an example of a PO being late to a receiving dock. Typically, the PO is late. If they're running basically very tight, the manufacturing person says, "Hey, where's that product?" They call the buyer. The buyer tries to figure out from the vendor where it's at, and you go through these steps to figure out how do you account for that, right? Usually ends up changing the schedule. So those decisions are very, very pattern oriented, and we can automate those. The other thing I see is a lot of pilot purgatory. There's a reason for that, right? I think people have done a lot of pilots and learned a lot of great stuff and done a lot of great things. But when you start thinking about how you scale out that pilot to multiple plants, you start seeing the limitations of the architecture you use or the approach you took, right? The things on the bottom are things that I think are key to this scale issue, right? The first thing is lack of specialized talent. The bottom line is that if you are expecting manufacturers to hire a bunch of data scientists to deploy and enable AI on the plant floor, that's going to be a challenge, right? Our philosophy is this: we have to develop solutions that can be used by the people manufacturers have. They are controls engineers, process engineers, quality engineers that spend a lot of time crawling over that equipment, looking at the OT environment. So we want to build tools that can be used by those folks. Are you going to need data scientists for the training of the model? Absolutely. That's no doubt about it. But think about applying the AI in manufacturing and using the resources you have, right? Last but not least, the IT and OT misalignment that we've had historically in manufacturing is now coming back to bite us with cybersecurity gaps, lack of knowledge on either side. So IT folks don't know a lot about OT and vice versa. And we're working to many customers trying to kind of align that overall. All right, a couple of data points from other sources. This is from the Manufacturing Leadership Council and some McKinsey studies. They were, I think, recently June, I put this together. So a couple of things. This is amazing to me. 28% of manufacturers have operational AI pass pilot stage. That's it. Many customers think they're, oh my God, we're so far behind. We haven't started anything. This is where you're at. It's not that far behind. We're in early days. We are in the first 10 meters of a marathon here, right? Couple areas. Manufacturing production is a key priority area for implementations. Also inventory management. I would have said inventory management first, just based on my experience. The good thing is that people are going to invest in AI, right? They understand the value. We're predicting it to rise, or MLC is predicting to rise to 96% by 2030. The next one I'll talk about is the lack of skilled personnel, AI governance, and risk management. That's the one that I really think is going to surprise a lot of people. It's one thing to say I'm going to develop a model, let's say a predictive maintenance model or a VIsionAI model deployed to the edge. Then think about this. Let's say I have 10 lines, 4 machines in each line. I got 40 machines in a plant. Let's say each one of those machines has a different predictive maintenance model or a combination of some other model. Who's going to manage all those ML inferences in the edge? That's where the real work's going to come in manufacturing, right? We don't think of it yet because we're not deployed out in scale, but figuring out, is this the right model to run? When is the time to basically retrain that model, right? Who has access to those models to make sure that people aren't basically making a change to something they're not supposed to? That's a real risk in manufacturing. Manufacturing is always going to be about execution, right? And this is why I love the ClearObject solution, because it's very, very tied to the floor and the edge where the work gets done, right? A couple other points as far as what we're seeing out there. So this is a view of our manufacturing data engine solution. It is a platform solution. And if you look at the bottom row, what you see there is all the GCP technology, Google Cloud technologies that exist in Google Cloud today. So things like PubSub, Dataflow, BigQuery, that's the same technology. There's nothing different there. What we decided to do is figure out how do we facilitate the use of those technologies in manufacturing specifically, right? So if people are going to use BigQuery for certain things in manufacturing, how do we facilitate that? And that's what manufacturing data engine is all about. Think of it as a capability layer for manufacturing on top of the GCP stack, right? And there's two aspects of this. One is on the right-hand side, the connecting to it. It's the biggest challenge people face, right? In a manufacturing plant, you can have a 4-year-old piece of equipment next to a 2-year-old piece of equipment. The 4-year-old one is running Allen Bradley Data Highway Plus. The newer one is running ControlLogix. Connecting to that is a challenge, right? Even multiple MESs, excuse me, and SCADAs out there is a common situation. So we developed a tool with our partner Litmus to really help people do that connection part at scale, be able to templatize certain aspects of it, use code to roll it out so you can actually get out there and connect to those machines. That's the first thing we solve for from our perspective. The second thing we solve for is this data doesn't have any context, right? If you connect to a PLC, and let's say you're connecting to a temperature sensor, sending out a data element, 150, is it Fahrenheit, is it centigrade? You have to figure that out. You want to tag that with metadata in terms of what line is it coming from. So we created a lot of tools to help you manage the data at ingestion with MD, the middle part there. As an example, using that 150 example again, let's say you're connected to a temperature sensor on a PLC. It's sending you the number 150 10 times a second. If you collect all that data and put it in the data lake in the cloud, that's a lot of data. 10 times a second for a month, let's put it that way. And so we said, look, we'd love that because we're driving the consumption, but that's not the right thing to do for the customer. We want the customer to control the data at the ingestion point. And that simple example for a certain use case, let's say that use case you only want to see the temperature if the temperature changes. You can, with MDE, say, look at this data stream that's temperature. Only send the data to the cloud when that number changes. So every time you see 150, it just puts it aside. I'm not interested in that. When it changes, you put it to the cloud. So you're, at the end of the day, you're making it much more effective to run a use case and lower costs overall. That's our philosophy. On top, you have all the different solutions that drive specific use cases. We've developed 4 ourselves just because we think they're universally needed by the marketplace. Our partners have hundreds of them. Obviously, ClearObject just showed you VisionAI. They have other ones also. We also believe in collecting to data sources. One of the best customer stories we have today is a customer who is connecting to SAP data to be able to put a sales order number literally at the machine level data when you're manufacturing something. So let's say you're creating a part, and you got all the data to create that part. We're creating a synthetic tag that says it's sales order 123, and it just keeps showing that. So when I go back and get a complaint on sales order 123, I can literally find that tag across the entire manufacturing process and see all the data associated with it, right? So this is kind of our view of the world. It is a platform. It's really about applying AI into manufacturing in a way that makes sense from our perspective. The tools underneath are continuing to be evolving. Vertex AI is what ClearObject use here. Vertex AI is attached or has our Gen AI app builder as part of that capability. So it's all there. Once you deploy MD, you have access to the full stack across the Google Cloud. A couple of lessons learned just from working with customers. I thought it would be beneficial for the team to hear that. So a couple of things. Data ingestion and contextualization are challenges. Number one issue with scale, right? Hard to do. And some of the things we talked about MD is trying to solve for that. Manufacturing will always be hybrid, edge and cloud. So Derek nailed it, right? There's no way in my mind that you're going to have a full cloud solution in manufacturing. You're always going to have edge. Even if you have no latency issue, the speed of performance of machines will dictate you to basically have an edge component, right? And MD allows you to essentially deploy those applications in containers to the edge and manage them. Look, optimizations occur when the information and process changes. We have a lot of people doing pilots and we're learning a lot, but how are you changing the way people work, right? Right now, we're very focused on dashboarding, showing them information. OE is a common metric. But at the end of the day, you have to figure out how do I change the way people work with AI and technologies. And then scaling from pilots to plant is a complex issue, right? A lot of challenges there, and people are working through that process on a case-by-case basis. A couple of best practices. Scalable architecture design is a must. Most of the customers I talk to that have, look, we've been talking about intelligent manufacturing for 10 years, right? Most people I talk to have already tried something. The people who have tried other approaches are stuck because of scalability of the architecture, just not there. You need to have a holistic data ingestion strategy, right? If you have an MES, fine, use the MES, connect to that database as opposed to going directly to the device. There's no rule that says you have to connect to the device. What we recommend is don't connect multiple times to the same device. Use the data where it's at and use it. Establish a data model. There is no universal data model for manufacturing. People ask me all the time. Unfortunately, there isn't one. So the most you can do is figure out how to create one that's gonna, realize it's gonna change. How do you add flexibility to that data model? And how do you use a metadata or metadata tagging sequence that makes sense, that can be adjusted? And last but not least, asset selection and sequencing. This is the biggest challenge I see. People start with a pilot and they figure out, oh, I just did a pilot on machine number 1, but machine number 1 is the only one of these I have, right? Or I just did a pilot on machine number 10, and by the way, that's the oldest version of that machine. We just upgraded to the newer version of all the other plants. So you got to make sure you understand the sequence and the selection of the assets, right? Because you want to multiply this out. And in some cases, the most challenging machine from a downtime standpoint may not be the best place to start, because you'll solve that problem and you're going to add value there, but you're not going to be able to scale out to other things, right? So that's a key insight to think about as you think about your program. A couple other things, and Derek touched on some of these. Value capture and accumulation. Our philosophy is this, that every single use case has to stand on its own when it comes to value. Every single use case has to have a business case, right? If you're ingesting data into the cloud, you have to have a reason why you're connecting to that device and sending to the cloud. If you take the approach, which we love from a consumption standpoint, I'm going to connect to everything. I have one customer who had 90,000 tags in the 90,000 tags a second being collected. Think about that in a plant. If you get everything in there, it's great for us for consumption, but it's going to bog you down. So every use case has to stand on its own. If you don't have a use case, then why are you ingesting the data, right? Change readiness and capacity. Look, we're notoriously bad at this, manufacturers, and when I say we, I'm saying the royal we, as far as change management and really understanding, is the organization ready for this? when you pick a plant, pick a site, keep that in mind. You may have the right asset to choose. You may have the right technology ready to go. Is that plant ready to go from a change management and change capacity standpoint, right? Do you have the right plant manager? Do you have the right lead in the plant? If a plant's in the middle of a major line upgrade, do you think they want to do a pilot on the old machine for AI? Probably not, right? Next thing is you want to evolve jobs, right? We're doing these things with AI to improve efficiency. That's the bottom line, reduce our cost of goods sold. But the other aspect of this is that manufacturers for the last 7 years, this is before COVID, have been struggling to fill open jobs. There's two things that are occurring, right? The average age of a manufacturing worker in the US is 52 years old, so a lot of people are leaving, right? And the new hires, well, first of all, people don't even want to work in manufacturing. They think it's dirty. They don't think it's high tech. And the people who do get hired last on average about 2.5 years. So that's a big issue, right? So when we think about AI use cases, you think about how do I change a job? To Derek's point earlier, right? If a human can inspect it, so can VIsionAI. Has anyone ever tried just for 10 minutes do a vision inspection job as a human? It is mind-numbing. It is mind-numbing. When I worked for a pharmaceutical, we had a terminal sterilization plant where the IV bags full of heparin would actually literally get pushed by a set of operators that were looking at the bag, looking for particulate. Think about that for 8 hours, right? There are jobs that simply don't make sense, and we can make them change. And then the last thing is the process changes, right? Figure out how are you going to change the process with this use case, right? You don't just think about AI and add a use case and say, we're going to do the exact same thing. Figure out how to change the process, make the process better itself once you enable that capability. And with that, I'm going to turn it over to Todd to manage our Q&A. Or maybe it's Mike. I don't remember. Sorry.
All right, over to you, Mike.
All right. Well, so I'll just go through the questions as they stand here. So I guess the first one came in is, how do we determine which process should be done on the edge versus in the cloud? And do I need specialized hardware on the edge? Well, that feels like a layup. I don't know. Derek or Luis, you want to?
I'll let Derek go with this one.
Yeah, no problem. So, really couple major reasons why you'd want to go on the edge versus in the cloud. First is around latency. Louise referred to it back to it, right? The speed at which these machines operate, it's just going to be better from a performance perspective. The second would be around bandwidth. Ultimately, if you have multiple vision systems within your manufacturing environment and you were trying to push all those streams up to the cloud, that's going to cause a lot of issues with your network. And, on that same is, Louise referred to, like, if you put all that data in the cloud, you're going to get overwhelmed. It's going to drive a lot of consumption, but ultimately, it's really going to drive costs up when it's not required. There is specialized hardware for the edge. Specifically, it depends on your use case, how specialized that hardware is. You get down into the selections of what is the actual cameras that you're selecting. But where the actual processing is occurring, then whether it's CPU, GPU bound, will require you to have some hardware there installed within the network.
Yeah, the only thing I want to add to this is that take a look at what existing hardware is on the edge already, right? Because there are a lot of use cases out there that nothing to do with use case where they have an edge device already, they have a server for, let's say it's an MES, something like that. You can use that, and for the most part, we try to stay away from specialized hardware where possible. So it's just CPU type stuff. I mean, maybe GPU in some cases, but that's pretty much it. Mike, back to you.
Luis, I think actually we'll have a question directed specifically to you. So,
Okay.
Luis, are you seeing certain subsectors of manufacturing embrace AI more quickly?
Yeah, it's a great question. And if anybody from Google leadership is listening, do not make this into a sub-verticalization conversation, which I'm opposed to. But anyway, so here's the thing. I think it's just the nature of the product, right? So high-tech manufacturing, semiconductor, PCB boards, all that type of stuff are embracing it much quicker, right? Because they typically have newer machines. You have a Ko Young SMT machine, stuff like that. They have newer machines. they tend to be very, very data heavy already. So they have a lot of data, a lot of historical data. And that's a gold mine. When you're talking about deploying an AI use case, you have historical data to train the model on, that's gold, right? So I see those areas. Second to that, so high-tech manufacturing. Second to that is really the auto manufacturers, right? And I say they're adopting it, but we all know it's slow going, but at least they started, right? And that's really market driven, right? That's market driven. If you, the example I give people all the time, if Tesla gets told, and I'm not saying Tesla's a great manufacturer, don't quote me like that, but if Tesla gets told that, hey, a windshield wiper motor has a defect by the supplier, and here are the 500 motors that are defective, Tesla can pull back those exact 500 motors. Those cars can be pulled exactly. Same situation with the big three. They have to estimate how many cars, and they have to say, when did the motor get to the dock? When did I start using it? Well, let's pull back 5,000 cars to make sure those 500s are captured, right? So it's a huge market-driven and customer-driven thing, right? And so those are two industries I would call out as far as adopting early. And then the rest, manufacturers are laggards. That's the reality of it. We're very focused on getting the product out the door every day. Very difficult to make major change in manufacturing. So back to you, Mike.
Great, thank you. That's a great answer. So maybe we'll send this one to Derek. So how long does it take to train a model to figure things out? You mentioned space between boards. What if I'm looking at specific defects in specialized manufacturing?
Yeah, great. That's a great question. When we come across a lot. So a couple factors that factor when you're looking at that. One would be, well, how often is that specific defect occurring? Based on that defect rate, how many samples of that would I capture? So, if you're 24/7 manufacturing and it happens, 5 times an hour, well, then you might be able to get to a pretty good sample size of, we've seen results of, 10 instances being able to train a model to start to identify specific defects. The other thing that you can do to try to speed that up as well, though, is depending on, how important is the classification of the defect, maybe more around, rather than knowing exactly what that defect is, training a model to look at what is a standard component look like versus then flagging that as non-standard. So then that can be an iterative process and a step towards then classifying it. So I'd say the sample set of 10 gets you a minimal viable model. 100, you could probably get a pretty performant model. That's kind of a general baseline from an AI perspective. And so, again, depending on your process, your flow, how much detail you want to get down to into identifying the defect and classifying it will impact that timeline. But there's some steps that you could take along that way to balance the risk versus the benefits.
Great, thank you. I think next question is for you, Luis, which is on the IT/OT leadership challenges. Is there a best practice you've seen work? How do you align goals?
Yeah, I wish there was. I'd write a book and make some money. Look, there's no easy answer. The thing that I think has been transformative in the sense of bringing people to the table in different conversations is security, right? If you say security is everyone's responsibility, which it is, and you task the IT/OT leaders with basically their joint ownership security, and you have to work together to figure out how to secure both sides of the wall, so to speak, right? Look, I tell operations leaders this all the time. If I was an operations leader today, I would literally call up my CIO and say, every system that's out here in these plants, they're yours. I don't want them. All I care about is the data. I own the data, you own the systems. And literally just walk away from those things, right? Focus on the data as an OT leader, right? And how do you get that data? Then what do you do? What do you use that data for? So instead of focusing on the actual systems that collect the data at the kind of the typical Purdue model level, at level 1, level 2, level 3, focus on the data itself as a target, and then let IT handle everything else. That's my advice. I give it all the time. It's not always taken, as you can imagine, but that's the nature of the beast, right? And as this thing evolves and OT gets busier with actually managing AI models on the floor, you'll see this happen, right? Because they'll be like, you know what? I can't deal with this. I'm going to try to figure out how to manage the ML models on the floor. I'm going to focus on that. You guys deal with the systems. So eventually you'll see that shift, in my opinion. Back to you, Mike.
Yeah. Well, last question, which I might take a first shot at, but I'll still turn it over to you, Luis and Derek, if you have other ideas. But I need to improve performance, but the owners aren't trusting of AI, family-owned business. Any advice on how I get buy-in from leadership? So this is my recommendation on any of, as far as like the sell up. And I think this is probably I would call it more of at least what I believe to be more of a universal truth. But the idea is like, look, start small, grab data, figure out the payback period, and scale up the results. And so what I mean by that is like, hey, like Derek talked about, like get a camera on there, you start to capture some of those results, do it in a small segment. You can actually see what kind of improvements you can forecast then based on what you're already seeing. And you can bring that data to the equation and say, hey, this is what we captured here. If we integrate this, we could get X from this, from just this camera. But if we did that across, that scales up, and now you're talking, millions that are coming back to the bottom line, pure profit. Like just you think about it, if I can reduce scrap, I mean, just something as simple but as impactful as scrap. Every ounce of scrap you save, every increase in quality, I mean, that's just flowing right to the bottom line. And so you just talk about like, what's my payback period? I take that small sample. If I integrate here, can I pay that back in 6 months, in 12 months? And then everything's profitable after that on whatever that investment is. And as you bring that intelligence in, and the thing is, as you go up, bring data. You bring data, you bring that, like, don't spend months on an ROI calculation. It's not necessary. Well, I would say for most companies, it's not necessary. Yeah, I mean, like, it might be nice. It may be something you do on the backside, but it's generally not necessary to kind of get that first decision on, like, hey, should I scale up? Do I still trust it? Am I making improvements? And then just keep bringing data, keep bringing results, keep bringing profit to the bottom line.
Yeah, great answer. I would just add this to that. It's a terrible challenge. I understand that, but I'm not trying to be flippant. The answer to me is don't start with AI. Start with, let's say, do you really want to start with predictive maintenance, an example, for a company that's kind of old school and, pushing it back against change? Start with, instead of predictive maintenance, start with condition-based monitoring. Just monitor the spindle load, monitor the pressure, temperature. Start with that, right? And then say, hey, here's what we're doing. Here's what we're doing with this data set, right? And here's what we can do with that data set if we add AI, right? And start with simple things. Try to use pre-trained models so they understand don't get bogged down by the complexity. Things like our anomaly detection API, which basically trains itself, is a good starting point also. So keep in mind, just focus on adding value on the analytics side of things first, and then work your way up to incremental AI use step by step. Okay, with that, back to you, Mike.
All right, thank you. That's it for the questions. So, I mean, I don't if anybody else had anything else, but we really appreciate, Luis. We thank you for your time, your insights, and what you bring from your work history, and then into Google, and then how Google's really helping up level the capabilities for manufacturing. I mean, I think it's fantastic. I think everybody really, I mean, I know I really enjoyed that. And Derek, thanks a lot. Really appreciate, really walking through the vision. I loved watching, and the truth is, I mean, I know Derek, we're on the same team, but I hadn't seen him actually break down, for an audience on exactly how the step-by-step, companies should really be thinking about how do they go, and it's not even just like use ClearObject, but really, how can you just go and bring vision into that? How do you go drive value from that? Because I mean, the truth is, I don't know if I've seen a business case when you're talking about manufacturing where you're incorporating vision that you can't, generate ROI off of. You're not generating value. I mean, I don't think we've walked into any customer where after we put it in, a system, they're like, oh wait, no, that didn't work. I mean, there may be challenges in scaling, but I don't think in any case we're ever seeing a point where there's not value. So, I mean, I think, again, like, just laying that out so people can understand kind of that and some of the hurdles, I think it was fantastic. So I really appreciated, Derek and Luis. It was fantastic. And thank you, everybody, for joining. We really appreciate your time.
Thanks for joining, folks. Appreciate it. Thanks, guys, for having me. Appreciate it.
Thanks, everyone.
Thanks a lot.